Hello everyone. In this video, we will learn about series and sequence and sigma notation. To begin with, let's have an example of a series and a sequence. 1, 2, 3, 4, and 5 is considered as a sequence. Series, you will simply add them and get its corresponding associated sum. This is another example of a sequence. Its corresponding series, simply add them, and the result is 7 over 12. With this, what then is a sequence and a series? A sequence then is basically an ordered list of numbers. It could be arithmetic, it could be geometric, or neither. It can be finite or infinite. So when you say finite, the sequence starts and ends. When you say infinite sequence, the sequence starts, but it has unlimited terms. Take note, this ellipsis here indicates that you can still extend its terms. While a series is basically a value you get when you add up the terms of a sequence, and it uses summation notation sigma. Now, let's have this example. Identify the first 5 terms of the sequence and give their associated sum. To begin with, 2 minus n. So to get the first 5 terms, so that would be from 1 until 5. So let's substitute. So 2 minus 1, you'll get 1. 2 minus 2, you'll get 0. And 2 minus 3, you'll get negative 1. Until 2 minus 5, you'll get negative 3. With this, let's get its associated sum. That would be negative 5. Another example, it's negative 1 to the power of n. So again, negative 1 to the power of 1 is negative 1. Negative 1 to the power of 2 is 1. Until negative 1 to the power of 5, you'll get negative 1. Getting its associated sum, simply get the sum of this and it will end up to negative 1. Next, let's have this. Let's review basic terms associated with series and sequence. So let's have this. This is an example of an arithmetic sequence. The other one is an example of a geometric sequence. So let's try to compare and contrast. So let's have this one first. So an arithmetic sequence, so 1, 3, 5, 7, 9, and 11. For this, there is a common difference. And how to solve for the common difference is simply subtract the recent term minus the previous term. So that would be 5 minus 3, you will get 2. 9 minus 7, still it's 2. So when you say an arithmetic sequence, in this case, the common difference is 2. So 1 plus 2, you'll get 3. 3 plus 2 will get 5, 5 plus 2 will get 7, and so on. So that is an arithmetic sequence. Now for geometric sequence, there is a common ratio. And how to solve for the common ratio, that would be the recent term divided by the previous terms. Like for example, 9 divided by 3, you'll get 3. Or 3 divided by 1, you'll get 3. So, to identify the terms in a geometric sequence, you will keep on multiplying the terms with the common ratio. So, 1 times 3 is 3. 3 times 3 is 9. 9 times 3 is 27, and so on. So, again, for arithmetic sequence, there is a common difference. For geometric sequence, there is a common ratio. Now, another. Finding the nth term. So, given this, if you want to know what is the nth term of an arithmetic sequence, we will simply follow this formula. That would be first term plus n minus 1 times the common difference. For example, identify the 6th term in this sequence. So that would be A6 is equal to, the first term is 1 plus, we're asked to find the 6th term, so that would be 6 minus 1 times the common difference, 2. So with that, you simplify, and the 6th term would be 11. Now, even if you're asked to find the 100th term, we will simply use this formula. Now, for geometric sequence, to find the nth term, the formula would be A of n is equal to first term times the common ratio raised to n minus 1. For example, in this case, identify the fifth term of this geometric sequence. So to do this, A1, or the first term, is 1. The common ratio is 3. And since we're asked to find the fifth term, so that would be 5 minus 1. Or that would be 3 to the power of 4, in which, when you simplify, that would be 81. So take note for the formula in finding the n term of arithmetic sequence and geometric sequence. Another, arithmetic means. So to get the arithmetic mean, or simply the average, that would be a term plus another term and divided by 2. So for example, identify the arithmetic mean of 1 and 9, or the first term and the fifth term. So that would be 1 plus 9 divided by 2. The result would be 5. So therefore, arithmetic mean of 1 and 9 is basically 5. Now, for geometric, that would be geometric mean. And the formula is multiply the two terms and get its square root. For example, identify the geometric mean of 1 and 81. So square root of 81, that would be 9. So therefore, the geometric mean of 1 and 81 would be 9. Okay, that's one, arithmetic series versus geometric series. So let's have this one. Find the sum of the first n numbers of this arithmetic series. So to do that, that would be n times first term plus the n term divided by 2. For example, find the sum of the first 6 terms of this series. So that would be S6 is equal to, n is 6, and the first term is 1, plus the sixth term is 11 divided by 2. So simplifying, we'll get 6 times 12 over 2, or that would be 36. Now for geometric series, find the sum of the first numbers. So that would be A1, or first term, times the ratio to the power of n minus the first term divided by common ratio minus 1. For example, find the sum of the first 5 terms. So this would be, first term is 1, common ratio is 3, and this would be 5 minus 1 over 3 minus 1. So 3 to the power of 5 is 243 minus 1 divided by 2. So we'll end up with 121. So take note for the formula in finding the first nth numbers for arithmetic series and for geometric series. Now, in case the geometric series is infinite, so when can you say it's infinite? If the common ratio is greater than -1 but lesser than 1. So to find the sum, this will be the formula. So this would be the first term divided by 1 minus the common ratio. So take note of this. Next. Now this is an example of a geometric series. So first thing first, find the common ratio. So take note, to find the common ratio, it's recent term divided by the previous term. So to find the common ratio, this would be 1/2 divided by 1, or the common ratio is 1/2. Another, find the sum of the first 7 numbers. So find the first 7 numbers and identify its sum. So to do that, A1, r to the power of n minus the first term divided by r minus 1. So let's substitute. First term is 1. The common ratio is 1/2. And so 7 minus 1 over 1/2 minus 1. So in this case, 1 over 2 to the power of 7 would be 1 over 128 minus 1. 1/2 minus 1 is -1/2. So simplify this. 1 over 128 minus 1 is -127 over 128 times -2. So therefore, the first 7 terms would be 127 over 64. Another, find the infinite geometric sum since the ratio here is 1/2. So to do that, this would be 1 over 1 minus 1/2. So 1 divided by 1/2. Or to get the infinite sum, the result would be positive 2. Another, this one. If the n term is 1 over 128, find n. So we'll use this formula. So take note, our a sub n is 1 over 128. Our first term is 1. Our common ratio is 1/2. Then n minus 1. We are solving for n here. So take note, in finding the exponent, we have to equate the base. So since our base is 1/2, we have to rewrite this to 1/2 base. So that would be 1 over 128. Rewriting this would be 1/2 to the power of 7. In this case, the bases are equal, so we can equate the exponent. So that would be 7 is equal to n minus 1. Or 7 plus 1, so therefore n is 8. So in this case, this 1 over 128 is the 8th term of this geometric series. Now let's have situational problems involving series and sequence. A display of books on a shelf in an old library consists of 50 books at the bottom, 43 books in the next row, and so on. If the pattern is an arithmetic sequence and the top row has 8 books, how many books are in display? So take note, the given consists of 50 books in the lowest row, 43 books in the next, and 8 at the topmost. So since this is arithmetic sequence, let's identify its common difference. So to do that, that would be recent term minus the previous term. So that would be 43 minus 50. So therefore, the common difference is -7. So let's identify as to what row is 8. So to do that, let's use this formula. So our a of n is 8. The first term is 50. So n is unknown minus 1 times the common difference, which is -7. So simplifying, so transfer 50 to the other side would be -42. So distribute this. This would be -7n. -1 times -7 is +7. So simplifying further, this would become -49 is equal to -7. Dividing -7 to both sides, so therefore n is 7. So in this case, 8 is located in the 7th row. So to find the total number of books on display, so we will use this formula. So this would be S of 7. So n is 7, the first term is 50, and the last term is 8. So simplifying this, we will end up with 203. So there are 203 books in display. Another, the mean proportional to 2 and another number is -4. Find the number. So take note, mean proportional. So you're talking about proportion here. So that would be geometric mean. So geometric mean, you will simply multiply and get the square root of the product. So in this case, our geometric mean is -4. The one term is 2 and the other term is unknown. So squaring both sides, we will end up with this, or that would be 16 equals 2x. Dividing both sides by 2, so we will end up with 8. A car depreciates 20% every year after its acquisition. What is the depreciated value of the car after 6 years if the original cost is 700,000? So take note, in the first year, the cost of the car is 700,000. In the second year, it will become 560,000. So how is this obtained? This is 80% of 700,000. So in this case, find the cost of the car on the 6th year. So A of 6. Our first term is 700,000. The ratio here is 0.8 or 80%. So how come it's like this? Because it depreciated. So from 100% less by 20. So what is left is 80%. To the power of 6 minus 1. So simplifying this, we will end up with 229,376. So therefore, after 6 years, the car will cost 229,376. Another. The population of a barangay is 7,500 in 2008. It increases 5% every year. What is its population by year 2019? So take note, 2008 is considered as the first year. In that case, the population is 7,500. The following year, it increases by 5%, so therefore it's 7,875. Then, by 2019, that would be the 12th year of the given. So in this case, we will use this formula, and we will have A of 12. The first term is 7,500. And take note, how come the ratio here is 1.05? So take note, the ratio here increases by 5%. So that would be 100% plus 5. So that's why it's 1.05 to the power of n, which is 12, minus 1. So simplifying further, we will get this one. It means that by 2019, the population of the barangay will be 12,827. Hello everyone. In this video, we will have sigma notation. Now, this is the summation notation. This is the symbol. F of 1 is considered as the summand or a function. I is the index of summation, A is the lower bound, and P is considered as the upper bound. Now let's have this example. Expand the given summation. So this is the summation of I, where I starts from 1 until 4. So basically, it's simply 1 plus 2 plus 3 plus 4, or you will get the associated sum as 10. Another. The summation of 2i plus 3, where I starts at 2 until 4. So to do this, this would be 2 times 2 plus 3, because we start at 2. 2 times 3 plus 3, and 2 times 4 plus 3. So simplifying this, we will get 7 plus 9 plus 11, or it is 27. Another, summation of I squared, where I starts from 1 until 5. So this would be 1 squared plus 2 squared plus 3 squared plus 4 squared plus 5 squared is equal to 1 plus 4 plus 9 plus 16 plus 25, or this is equal to 55. Write its expression in sigma notation. So we're given here 1 plus 1/2 plus 1/3 until 1 over 100. So with this one, we can easily write the sigma notation as the summation of 1 over I, where I started from 1 until 100. Or we can rewrite this to the summation of 1 over I plus 1, where I starts from 0 until 99. Another example. So given this, 7 plus 14 until 70, let's rewrite this in sigma notation form. So to do this, let's identify first the interval of the given. So take note, from 7 going to 14 until 70, we keep on adding 7. So the first term is 7, and the common interval is plus 7. So the summation here would be the summation of 7n, where n starts from 1 until 10. So take note, please do not be confused. We can use n or we can use I. So that would mean the same thing. Or another way of rewriting this could be the summation of 7n plus 7, where n starts from 0 until 9. Now take note, in rewriting expression in sigma notation, you have to consider the first term. and identify the pattern, whether it has a common ratio or common difference. Now let's have another example. Now in this case, 3, 6, 12 until 192. So the first term here is 3. So let's identify the pattern. So with this one, from the first going to the succeeding terms, we keep on multiplying by 2. So 3 times 2 is 6, 6 times 2 is 12, and so on. So with this, we can rewrite the sigma notation as the summation of the first term is 3, then 2 to the power of n, where n starts from 0 until 6. Or another way of rewriting this would be the summation of 3, quantity 2, n minus 1, where n starts from 1 until 7. Another example. Negative 5, negative 9 until negative 29. So the first term here is negative 5, and getting the succeeding terms would mean we keep on subtracting by 4. So negative 5 minus 4 is negative 9. Negative 9 minus 4 is negative 13 until negative 29. So take note, the first term is negative 5 and the common difference is negative 4. So writing the sigma notation here would be negative 5 minus 4n, where n starts from 0 until 6. Or I can rewrite this as negative 4n minus 1, where n starts from 1 until 7. So take note, in rewriting expression to sigma notation, it really takes a lot of analysis. So please take note of that. Now, let's have these different properties of sigma notation. Let's begin. Now, these are some of the useful formulas if we are going to solve problems involving sigma notation. So, the summation of I, where I starts from 1 until n, would be n times n plus 1 over 2. And the summation of I squared, where I starts from 1 until n, we will get this. So let's prove or how the first formula is obtained. So let's have this summation of I. So that would mean 1 plus 2 plus 3 until n. Or we can have this as n times n plus 1 over 2. So with this one, to get the sum of the first n terms of a arithmetic series would be n times the first term plus the last term divided by 2. So let's substitute this. N, the first term is 1, and our last term is n. So simplifying, we go back to the original given. So take note of this formula. So mostly we will use the first two. So this is for the second proof of the second formula. So just the same thing. So let's have this. So the first property is summation of constants. So meaning the summation of a constant from 1 until n would simply constant times n. For example, summation of 4 from 1 to 10 would be 4 times 10 or 40. Another, 6 from 1 to 15 is 6 times 15 or 90. So simply multiply. Another, summation of a constant and a function. So this one. So for example, what is the summation of 4i? Or that would be 4 times the summation of I. So in which it is n times n plus 1 over 2. So this would be 4 times 8. 8 plus 1 is 9 over 2 equals 144. So take note, the summation of the terms 4i from 1 to 8 is 144. Another, the summation of 5i. So this would be 5 times 20 times 21 over 2 is 1050. Another, the summation of 2i squared would mean 2 and the summation of I squared. So take note here, this would mean 2 times 10 because it's the highest upper bound times n plus 1, which is 11, quantity 2n plus 1. So 2 times 10 is 20 plus 1 over 6. So simplifying, it's 770. So this would mean the summation of 2i squared from 1 to 10 is 770. So meaning, need not to really expand it to get the sum. We can use some properties of notation. Another, summation of functions. So, for example, summation of 4i plus 3 from 1 to 8. So this would be 4 summation of I from 1 to 8 plus summation of 3 from 1 to 8. So this would be 4 quantity 8 times 9 over 2 plus 8 times 3. So therefore, this would be 168. Another, summation of 5i minus 7 from 1 to 30. So this would mean 5 times 30 times 31 over 2 minus 30 times 7. So this would mean 2,115. Now, let's have this. For example, 4i plus 3. So again, the upper bound is so big that if you want to really expand it, it would really take time. So we'll use the different properties. So this would be 4, 50 times 51 over 2 plus 3 times 50. So simplifying, we will get 5,250. For this one, 4i squared would mean 4 times 20 times 21 times 41 over 6. So take note, this is n plus 1, and this is 2n plus 1 over 6. Or this is 11,480. Another. This is 2i squared minus 3i from 1 to 30. So this would be 2 times 30 times 31 times 61 over 6 minus 3 times n and n plus 1 over 2. So simplifying, we will get 17,515. And the last, we'll have here 3 times 100 times 101 times 201 over 6 minus 2 times 100 times 101 over 2 plus 4 times 100. So simplifying, we will get 1,05,350. So that's all about summation notation. Thank you.